Bypassing the generic queue engine for task-to-task signaling saves 45% of execution time during a typical context switch on an ARM Cortex-M architecture. Every binary semaphore created via the application programming interface requires approximately 80 bytes of heap space to store the queue structure and the event list pointers. Task notifications require 0 additional heap allocation because they utilize a single 32-bit integer already present inside the task control block structure. When a task calls the take function on an empty semaphore, the kernel must move the task state from the ready list to the delayed task list. Direct notifications skip the search through the event list because the target task is already known, reducing the instruction count for the scheduler dramatically. A binary semaphore acts as a simple flag, where the give operation sets the count to 1 and the take operation resets it to 0. By using the notify give function, the task notification value increments. The corresponding notify take function can then decrement or clear the value upon receipt. Unlike semaphores, a single task notification can act as multiple event flags by setting individual bits within the 32-bit notification value. Counting semaphores are limited by the maximum value defined during creation, whereas task notifications can count up to 4 billion events without extra configuration. A significant disadvantage of task notifications is that only one specific task can wait for a notification at any given time. Semaphores allow multiple tasks to block on the same resource, ensuring that the highest priority task is unblocked first when the semaphore is released. Signaling from an interrupt service routine is a primary use case for both primitives, but the implementation details differ in the kernel calls used. In FreeRTOS, any call from an interrupt context must use the from RSR suffix to ensure the correct kernel entry point. The function xtask_notify_give from ISR provides the fastest path to wake a task from a hardware interrupt, often saving several dozen clock cycles per call. The higher priority task woken parameter must be checked to determine if a context switch should occur before the interrupt service routine exits. Task notifications allow the sender to overwrite the previous value, providing a way to update status information without increasing the notification count. The ESET_value without overwrite action ensures that data is not lost if the receiving task has not yet processed the previous notification. The xtask_notify_wait function accepts parameters to clear bits on entry and exit, providing fine-grained control over the 32-bit state. Setting the bits to clear on exit parameter to all ones effectively resets the notification value back to 0 after the task wakes up. While mutexes support priority inheritance to prevent priority inversion, neither binary semaphores nor task notifications possess this mechanism. Using task notifications for resource management is risky because they do not track ownership, making it easy to create a deadlock situation. A common design pattern is to use a task notification to signal that a new data structure is ready in a pre-allocated buffer. Instead of sending a copy of the data, the notification value can be used to pass the memory address of the data buffer directly. Because the notification value is stored inside the task control block, it is more likely to be in the data cache when the task runs. Task notifications are enabled by default, but you can explicitly set config use task notifications to 1 in the FreeRTOS configuration file. Applications using only task notifications result in a smaller binary size, as the linker can exclude the heavy semaphore and queue logic libraries. Runtime trace tools like Percepio Tracealyzer can visualize task notifications as discrete event points on the timeline, helping to debug timing issues. Since FreeRTOS version 10.4, each task can have an array of notifications, allowing for independent signaling channels for different modules. To use a specific notification slot, the index parameter must be provided to functions like xtask_notify_indexed or xtask_notify_wait_indexed. Using task notifications instead of semaphores within high-frequency interrupts can reduce the total time the processor spends inside the interrupt context. Semaphores must be created before use, usually during initialization. Task notifications are always available, eliminating the need for a creation step. Because notifications do not use handles that point to external memory, you avoid the common bug of signaling a null semaphore handle. While semaphores can be created statically to avoid the use of a heap, it still requires defining a static variable for the buffer. Accessing a semaphore while the scheduler is locked will lead to an assertion failure, whereas notifications have different internal locking requirements. For a UART driver, use a task notification to signal the completion of a direct memory access transfer to the managing task. This direct signal allows the task to remain in the blocked state, consuming 0 central processing unit cycles until the hardware is ready. Event groups allow waiting for multiple conditions simultaneously, but task notifications are much faster if the task only needs to wait for one source. To send a notification, the sender must have access to the task handle of the receiver, typically obtained via the task create function. A task can notify itself to defer processing to a later time, effectively placing an event at the end of the ready queue. The eNotify action enumeration includes options like eSetBits, eIncrement, and eSetValue with overwrite to define how the 32-bit value is updated. Semaphores follow the more traditional real-time operating system design patterns, making code slightly more portable to other operating systems like POSIX. The FreeRTOS kernel uses the task notification mechanism internally for several features because it is the most optimized path available in the source. Both mechanisms support timeouts, where the task will unblock after a specified number of ticks if no signal is received. Always check the return value of the take or wait functions to distinguish between a successful signal and a timeout event. You can inspect the notification value directly in a debugger by looking at the task control block offset for the specific task. The increment operation in task notifications is atomic within the kernel, preventing race conditions when multiple sources notify the same task. Use semaphores for multitask synchronization and resource locking. Use task notifications for one-to-one signaling and maximum performance in drivers. Replacing all binary semaphores with task notifications in a typical embedded application can increase total system throughput by up to 5%.